Now moving ahead to this question, and the question is, a tuning fork vibrates at 264 Hz. The shortest length of a closed organ pipe that will resonate with the tuning fork is 33 centimeters, 65 centimeters, 75 centimeters, or 95 centimeters. Now understand this statement. We have already studied that for a closed organ pipe or an open organ pipe, there will be certain harmonics of vibrations which is traveling inside the pipe. Right? This much we know. Now, if the question is saying that the organ pipe should resonate with the tuning fork, that simply means that one of the harmonics of the wave which is traveling inside the pipe should match with the frequency of the tuning fork. Got it? One of the harmonics of the oscillations which is traveling inside the pipe should match with the frequency of tuning fork. That is what the question means by saying that it should resonate with the tuning fork. Correct? Okay. So now moving further. If we recall our knowledge, we know that the frequency of vibration is given by NV by 4L for a closed organ pipe. Right? F is equal to NV by 4L. Now, let's rearrange this equation. L is equal to NV by 4F. Correct? In question, we have been told that V is equal to 350 meters per second. What else? We have been given frequency as 264 Hertz. Although the frequency is of tuning fork, but the question is saying that this pipe should resonate with the tuning fork. That means we have already said that one of the harmonics should match with 264 Hertz. Correct? Got it? Okay. So now, coming back to the question. In question, it is written that what should be the shortest length? It is saying what should be the shortest length. Right? So, from this equation, we can say that V is constant. Right? V is given as 350 meters per second, and that is constant. That is not going to change. Frequency is going to remain as 264 Hertz. That is also not going to change. Now, what can we change? N. We can change N. If N is minimum, L can be minimum. If N is maximum, L should be maximum. Correct? But here we cannot figure out something as maximum, but we can figure out as minimum. Right? What is the minimum value of N we can take here? It is 1. Correct? If we write N equals to 1, then L equals to V by 4F. And this will be the minimum value of length of the organ pipe so that this organ pipe resonates with the tuning fork. Got it? Understood the question, understood the concept. Now is the time for calculations. Correct? Okay. So, V is 350 by 4 multiplied by frequency. Frequency is 264 Hertz. And if you calculate it, what do you get? L equals to 0.33 meters. L equals to 0.33 meters is the minimum length of the organ pipe so that this organ pipe resonates with the tuning fork. Got it? Okay. Now moving on to the options. Option A is saying 33 centimeters. We have calculated as 0.33 meters, and that is why in centimeters it will be 33 centimeters, and hence A is the correct answer for this question. A cylindrical tube open at both ends has a fundamental frequency F in air. The tube is dipped vertically in water so that it has water up to half the height. Now the fundamental frequency of the air column is now 4F, 3F, F or 2F. So here we have two cases. In one case, we have an open organ pipe. Let's say this is our first case, this is our second case. Let's say the length of this pipe is L. Now, talking about the first case. In first case, it is given that the fundamental frequency F0 is F. Now this is an open organ pipe, correct? If this is an open organ pipe, what should be the fundamental frequency? Tell me. It will be V by 2L. Is that fine? Yes. Now coming to the second case. In second case, this open organ pipe has been dipped in water. Up to what height? Up to half the height. So this length will be L by 2. Correct? Now where does your imagination drives you? In second case, we can see that we have a closed organ pipe. A closed organ pipe of length L by 2 above the water. Is that fine? Is that correct? A closed organ pipe of length L by 2 above the surface of water, right? So here we have a closed organ pipe of length L by 2. Now what should be the fundamental frequency in second case? Tell me. It will be F0 is equal to V by 4 LC. LC, the length of the closed organ pipe. And in this case, it is L by 2. So we can say this will be V by 4 into L by 2. And finally, this will be equal to V by 2L. Correct? Now see, this is 1. This is 2. In both the cases, the fundamental frequency came out to be V by 2L. That means in the second case also, the fundamental frequency is same as the first case, which is equal to F. Correct? Now the question is asking that what should be the fundamental frequency of this closed organ pipe when it is dipped in water up to half the height. Now from our calculations, we can see that it should be equal to F, which is equal to V by 2L. Correct? Both are equal, as you can see from 1 and 2. Both are equal, right? So, from the options, we can say that the fundamental frequency of the air column is now F only. It is not going to change because from our calculation, we have got that the fundamental frequency for the second case will also be F, V by 2L. And that is why option C is the correct answer for this question. In a closed organ pipe of length 105 centimeters, standing waves are set up corresponding to the third overtone. At what minimum distance from the closed end a pressure node is formed? We have studied about two types of waves. First is displacement wave. Displacement wave. Second one is pressure wave. Correct? Now from our previous knowledge, we know that there is a phase difference of 90 degrees between displacement and pressure wave. Correct? That means wherever there is a node formation for displacement wave, there will be an antinode for pressure wave at the same point. Or in other words, oppositely, wherever there will be a node for displacement wave, there will be an antinode for pressure wave. Is that clear? Now the question is saying, at what minimum distance from the closed end a pressure node is formed? A pressure node. So at that point, wherever a pressure node is formed, there will be an antinode formation for displacement wave. Correct? Now till now, in all the problems we have been dealing with displacement wave. So let's deal with the displacement wave here as well. The question is saying about pressure node, we are going to figure out the displacement wave antinode. Correct? Is that fine? Okay. Now, as you can see from the figure, here we have a displacement wave and we have to figure out at what minimum distance from the closed end an antinode will be formed for this displacement wave. Is that clear? Okay. So let's say this position A is our closed end. Now after the closed end, as we move further, at position B, we can find an antinode. Correct? and we have to find the location of this antinode. We have to find the distance of this antinode from the closed end. So how much is this distance? This distance is lambda by 4. The distance between node and antinode of any wave is lambda by 4, right? No need to explain that. Yes? Okay. So basically, we have to find lambda by 4 for this situation. Now this is a closed organ pipe. If it is a closed organ pipe and we talk about overtones or harmonics, the fundamental frequency will be V by 4L. Correct? The first overtone will be 3V by 4L. Odd multiples, correct? The second overtone will be 5V by 4L. And the third overtone will be 7V by 4L. Correct? The question is talking about the third overtone, right? This diagram is corresponding to the third overtone, 7V by 4L. So basically, the frequency we have to consider is F3 equals to 7V by 4L. Now let's rearrange this equation. If we rearrange it, this will be F3 by V is equal to 7 by 4L, or let's say L equals to 7V by 4 F3. Correct? Alright. Now V by F3, if you look at this term, V by F3, what is velocity by frequency? For a wave, speed by frequency is given as the wavelength of the wave. Correct? So we can write L equals to 7 lambda by 4. Fine? Or lambda is equal to 4L by 7. Any problem till now? The wavelength of this wave is given by 4L by 7, where L is the length of this closed organ pipe. Correct? What we have to calculate? We have to calculate lambda by 4. Lambda by 4. Correct? So let's remove all this and get to what we want. Lambda is equal to 4L by 7. Now what will be lambda by 4? Lambda by 4 is equal to 4L by 7 divided by 4, which will come out as L by 7. And this is what we have to calculate, right? Now in question, the length of this pipe is given as 105 centimeters. Correct? So L by 7 will be equal to 105 by 7 equals to 15 centimeters. So lambda by 4 is the minimum distance where we can find an antinode for displacement wave or a node for pressure wave. Correct? Now if we calculated, by our calculations we got that the wavelength is given by 4L by 7 in this case. Correct? Now lambda by 4 will be given by L by 7. L is given as 105, and that is why L by 7 or lambda by 4 came out to be 15 centimeters, which is the minimum distance where we can find a node for pressure wave or an antinode for displacement wave from the closed end. Correct? See it once more, analyze it. This is a question of analysis. That's it. Correct? Okay. So what is our answer? Our answer came out to be 15 centimeters, and that is why. Which option will be correct? Option B is the correct answer for this question. Two waves represented by y1 is equal to 3 sine 2000 pi t minus 50x and y2 is equal to 3 sine 2008 pi t plus 50x are approaching each other. Now the number of beats heard per second will be number of beats per second. That means we have to calculate the frequency of the beats formed by these two waves. Correct? Okay. So here we have two waves. The equation goes like y1 is equal to 3 sine 2000 pi t minus 50x. The first one. For the second one, y2 is equal to 3 sine 2008 pi t plus 50x. We also remember the beat frequency formula, right? FB is equal to mod of F1 minus F2, where F1 is the frequency of one wave and F2 is the frequency of the second wave, right? Okay. Now, if we write the equation of the wave, y is equal to a sine omega t minus kx. This is our general equation, correct? Now, if we compare the first wave, the equation of the first wave with this general equation, we can say for y1, omega 1 is equal to 2000 pi. Is that right? Yes. And for y2, omega 2 is equal to 2008 pi. Correct? Okay. So we have figured out that omega 1 is equal to 2000 pi and omega 2 is equal to 2008 pi. Can we calculate F1 and F2 from here? Of course, because we know that omega is equal to 2 pi f. Omega is equal to 2 pi f. Correct? Okay. First, omega 1. It is 2000 pi. 2 pi f1 is equal to 2000 pi. Right? From here, f1 will be 1000 hertz. Correct? Similarly, for omega 2 is equal to 2008 pi. So, 2 pi f2 is equal to 2008 pi, and finally from here f2 is equal to 1004 hertz. Correct? Now, FB is mod of f1 minus f2. So, what will be the value we will be getting when we subtract these two frequencies? 1004 minus 1000, 4 hertz, right? 1004 minus 1000, it will be 4 hertz, and that will be the beat frequency in this case. Correct? Okay. So 4 hertz is our correct answer, and that is why option B is the correct option for this question. Two waves whose equations of displacement of particles in the medium are y1 is equal to 4 sine 500 pi t minus 25x and y2 is equal to 2 sine 506 pi t minus 30x. How many beats will generate due to the superposition of the two waves, and what will be the relation between maximum and minimum intensity? Alright, so here we have our two waves. y1 is equal to 4 sine 500 pi t minus 25x and y2 is equal to 2 sine 506 pi t minus 30x. And what about beat frequency? Beat frequency will be given as FB is equal to mod of F1 minus F2, right? Where F1 and F2 are the two frequencies of the waves. Okay? Alright. So now, the general equation of waves, y is equal to a sine omega t minus kx. If you compare these two equations with this equation, the general equation, we can say that for y1, omega 1 is equal to 500 pi. Is that true? Yes. For y2, omega 2 will come out as 506 pi. Why we are doing that? Because if we know omega, we can figure out f, the frequency, right? Because omega is equal to 2 pi f. Alright? Okay. So 2 pi f1 is equal to 500 pi, and from here f1 will come out as 250 hertz. Talking about y2, 2 pi f2 is equal to 506 pi, and f2 will come out as 253 hertz. Easy. Now we have f1 and f2. Easy to find fb. Correct? Okay, so let's do that. fb is equal to f1 minus f2. fb is equal to mod of f1 minus f2. And from our data, from our calculations, f1 is 250, f2 is 253, and if we take mod of it, we will get 3 beats per second. Correct? Is that true? Okay. So now first thing sorted. We have calculated beat frequency. Now we have to calculate the ratio of maximum to minimum intensity. Maximum to minimum intensity. Now always remember, intensity is directly proportional to the square of amplitude. Intensity is directly proportional to a square of amplitude. Now we have to calculate the ratio of maximum versus minimum intensity, right? maximum intensity by minimum intensity. That is the ratio we have to calculate. So first of all, we need to know that what is the maximum amplitude and what will be the minimum amplitude, right? Okay. So here you can see the formula I max by I min is equal to A max by A min whole square, right? Now A max is always equal to A1 plus A2. The amplitudes of the respective waves A1 plus A2, and A min, the minimum amplitude is given by A1 minus A2, right? Okay. In our case, if we look at the equations of the wave, let's see. It is 4 sine 500 pi t minus 25x. For the first one, the amplitude is 4. For the second one, it is 2. Okay. So A1 and A2. A1 is 4. A2 is 2. Easy to calculate A max and A min, right? Okay. So A max is equal to A1 plus A2. 4 plus 2. It will be 6. A min is equal to A1 minus A2. 4 minus 2. It will be 2. Now that we have A max and A min, we can calculate I max by I min. Yes? Okay. So I max by I min is equal to A max by A min whole square. Right? So A max is 6, A min is 2, and we have to square them up. Now if you go further into calculation, this will come out as 9 by 1. 2 3s are 6 and 3 square is 9. Right? So from here we can say I max by I min is equal to 9 by 1, and that is why I max is equal to 9 times I minimum. So we have to calculate two things, right? First, beat frequency that we got as 3 Hertz. Second, the relation between I max and I min, we have got I max is equal to 9 times I min, right? Okay, so now let's test the options. Option B is saying that beat frequency will be 3 beats per second and I max is equal to 9 I min, which is matching with our answer, and that is why option B is the correct option for this question.